it working?
Well, I assume so. Let's see if the sound's on. I suppose the sound's on. Otherwise, I'll just be able to watch. All right. So, so we're going to have a go. So basically, the way you approach this is you start with 3 equations, 3 unknowns. Okay, you need a system of 3 unknowns and 3 relationships, 3 equations. You take 2, you take pairs, and you eliminate 1. So for example, I would take the first and second one and get rid of z, and I create another new one. And then I take the first and third, a different combination, and I eliminate z, and then I've got 2 new equations with only x and y, and then I work my way through that. All right. So somewhat of a kind of thinking through. You kind of then substitute the values back in as you go. So let's have a look at a couple of examples. So it takes a fair amount of time, to be fair, and you just need to sort of think it through as best you can and take the principle of, okay, first and second ones, let's eliminate z. Second and third one, let's eliminate. It doesn't have to be you can eliminate any of the variables as long as it's the same one. So let's have a look. So we've got the following 3. I like to write them one above the other. X plus y minus z equals 7. X plus y plus 2z equals, I put a line through z so it's kind of clear that it's not 2. 3x plus y minus 2z equals 19. And we're going to label these 1, 2, and 3. Alright, we've got 1, 2, and 3. So now we've got these combinations, and I'm going to say, alright, well let's use the first and second one to get rid of one of the 3. Now, which one am I going to get rid of? I'm going to suggest we're going to first start by getting rid of the y's. Well, because we've got y, y, and y. Whereas I've got x, x, 3x, so I'd have to multiply, z, 2z, 2z, so I'd have to adjust one of those, but the y's I can just do by no multiplication at all. So here's how we do it. So the first 2, I'm going to do the following. 1 minus 2. Now this is going to be even easier than the second example because I'm actually going to have the function of eliminating, right, more than 1. But let's see how we go. So I'm going to do 1 minus 2. And we're going to do 1 minus 2 is equal to x minus x is 0. Oh, I'll change to x minus x is 0. Y minus y is 0. And then I've got negative z minus 2z. So minus 3z is equal to 7 minus 1, which is 6. Alright? Now, in this case, in this example, actually I've gotten rid of the x and the y. So I've been given a solution for z, which is equal to negative 2. Alright, we've got it equal to negative 2. I still have to find what x and y are, so I'm going to do that in a moment. So we can do that in the following way. Yes?
Isn't that 2z, not 3z? Oh, okay.
No, because it's negative z minus 2z.
Right.
Yep,
Okay.
negative z minus 2z. So we end up with z is equal to negative 2. If your preference is to say z, I guess that's fine. I'll accept that, but you know, that's just different people pronounce it differently. Yeah, look, but no judgment. You know, it's accepted. Even the Wiggles in their alphabet song will sing Y, Z, or Z. The ending of the Wiggles song is Y, Z, or Z. Now I know my ABC.
They accept the
Look, it's just different. It's just the way it is now. So that's okay. All right, here we're going to do. We're going to sub z equals negative 2 into 3 and 1. Now, why do I do that? Because I need another 2 equations. I need another 2 equations which are going to allow me to solve it. So I've used 1 and 2 as a combo. So now I'm going to take my value for z, substitute into the first one and the third one. It could be the second and the third. It would give me a different combo. Point is, I need a different combination of 2. Because x and y are both the same in these 2, I wouldn't be able to solve it with these 2 anyway, right? So I need to use that and be able to do it with the third one. So sub z equals minus 2 into 3 and 2. So here we go. into equation 1, we're going to get x plus y minus minus 2 equals 7. So that gives me x plus y equals 5. And then that's my new kind of equation number 4, I'm going to label it as. Then into number 3, we have 3x plus y minus 2 times minus 2 equals 19. So that gives me plus 4, so I'm going to subtract the 4, 3x plus y equals 15. At this point, I'll pause and say, are there any questions as to how I'm getting these values or these results? Alright, so you notice now I've eliminated, well in this case I got rid of 1, I found the solution to z, which is nice. Now I've got expression for x plus y equals 5 and 3x plus y equals 15. Okay, so now we can use those two to solve. How am I going to eliminate using 4 and 5? Any suggestions? Suggestions for 4 and 5?
Substitution.
You could substitute. There is something that matches up nicely with the two of them. I could do that, but then I'd get fractions. What is it that's the same about this number 4 and this number 5? There's a y in both, which is the same sign. There's a y, so I can just do 4. Well, I'm going to do 5 minus 4. The reason is 5 is larger, so I'm going to do 3x minus x gives me 2x. Y minus y, it gives me 0. And then 15 minus 5 gives me 10. So we get 2x is equal to 10, x is equal to 5. We're almost finished. So now, I simply need to say, we find y. Alright, so sub x equals 5 into, I'll say number 4, because that's going to be the easiest. 5 plus y equals 5, so y is equal to 0. So after all that work, we have been able to find that the values are x equals 5, y equals 0, and z equals. The solution is x equals 5, y equals 0, and z equals negative 2, which is what we have. And that's the solution. Alright? All happy with that? To see how we've done that. So you start with a pair, get rid of 1, if possible 2. This was a nice example, we got rid of 2 variables. But not usually, there's all kinds of cases for this. If you get into this more, which is kind of in vector analysis, vector calculus and things like that in 3 dimensions, basically you then look at different cases where vectors cross in a point or vectors cross 2 cross and 1 is parallel. There's all kinds of different variations. But, we don't quite get into that sort of 3-dimensional, coordinate geometry. We're just kind of looking at it as a system of equations. Any questions? Any questions?
So how would you graph this?
Yeah, the graph for all of these 3 things are, I'll show you actually at the end. I'll pull something out, but they're planes. Planes in 3 dimensions. So x plus y minus z equals 7 represents kind of a plane, like imagine this wall. And then x plus y plus 2z minus 1 is a different plane at a different angle, and then the third one is a different plane. And this has shown that they actually intersect at a single point, which is incredibly rare actually, because they can intersect at all kinds of, with forming lines and different things. So, anyway. And that's what happens when you take 2 planes and they intersect, you get a straight line. So that's why you can get rid of one of the variables and you kind of can see it as a line on a plane. That's the kind of the way it works. Yeah. Okay, let's do the second one and see how we go with it. So this one, we're using P, Q, and R. I'm going to start by doing it as one above the other. 2P plus 5Q minus R equals 25. 2P minus 2Q minus R equals minus 24. Australians don't roll their R's at all, because you go to the States or something, or in Ireland. They like to roll their R's, don't they? But anyway, that's completely not relevant. 3p minus q plus 5r is equal to 4. Okay. So that's equation 1, equation 2, equation 3. And we are going to attempt to solve this. Now, we want to get a pair of them and eliminate one of the variables. Here's what I'm going to do. I'm going to eliminate r from the first two. We've got negative r and negative r, so I'm going to subtract 1 from 2. And I think actually this one as well, we end up getting rid of another, which is surprisingly convenient, but anyway, that's okay. 1 minus 2, so that's what we're going to do. So 2p minus 2p is 0. 5p minus 2q is 7q. Negative r minus negative r is equal to 0. And then this one we get 25 minus 24 is 49. So 7q is equal to 49. We get q is equal to 7. Alright, so now again we're in a situation where we found the variable, and you could go ahead and solve that one by subbing q into, again you could do 2 and 3 or 1 and 3, it doesn't matter, it just has to be a different combo. Sub into, let's do 2 and 3 this time, and so we get 2p minus 2 times 7 minus r is equal to negative 24. And if we do that, it's negative 14, I'm going to add it, we get 2p minus r is equal to minus 10. And then we're going to get 3p minus 7, sub it in, this is in number 3, I'm subbed it into, e plus 5r is equal to 4. If we add the 7, you get 3p plus 5r is equal to 11. Now I think you could go ahead and solve that and be able to find as a solution, alright? So I just realized I may not have put the exercise in the OneNote, which I will do right now, and have a go. But finish this one off first, see if you can just solve this. So now we've got two equations with 2 variables. It's a case of simply solving this one simultaneously. Okay, thanks.